Hello, and welcome to this presentation on rocketry. Today, I'm going to teach you the basic parts of the rocket, as well as what they do. So starting at the tip of the rocket, we have our nose cone. Now this is the part of the rocket that makes it more streamlined and allows it to effectively slice through the air. There are many different sizes and shapes of nose cones, and their uses depend on how fast the rocket is traveling. For a rocket that is traveling very fast, this longer, skinnier nose cone, like this, is going to be more efficient. Whereas for a rocket that's traveling at a slower speed, this shorter, more elliptical nose cone is likely going to be better. Then, right below the nose cone, we have our payload bay. And this is what houses the cargo of the rocket. And our cargo changes from year to year. It can be something such as this rover, which is meant to deploy once the rocket lands on the ground and then be able to move around. Or it can be a payload that itself is intended to fly, such as this drone, which once again would be deployed after the rocket lands. Then we have our main parachute bay, and this is where the parachute of the rocket is housed. And it is very important because this is what allows the rocket to safely return back to the Earth. Directly below that, there's the electronics bay, and this houses two altimeters. Both of these serve to make sure that the parachute comes out of the rocket at the correct altitude. And there are two of them, so that if one of them fails, the other one will do the job. And finally, we have the fin can at the end of the rocket. Now this is what houses the motor of the rocket, allowing it to fly, as well as holds the fin on the body. The fins are important because they make sure the rocket flies in stable flight. If there were no fins, it is likely the rocket would go a little bit off of the launch pad before doing several circles and crashing back into the ground. One commonality between most fins is that they are longer at the base than they are at the tip. Now this does not have to be this way, however when fins are made this way with a tapered design, they are more efficient and reduce the air resistance on the rocket. These fins are trapezoidal, however there are many different types of fins that can be used. Now we're going to talk about the forces on the rocket, as well as what the flight path of the rocket is going to look like. So when we ignite our motor, the motor pushes hot gases out of the back of the rocket. And this creates a force which we call thrust. And this thrust acts upward, pushing the rocket into the sky. Now, we also have two more forces which are slowing the rocket down. We have the weight of the rocket, as well as the drag, or air resistance, on the rocket. And from this, we can see why it's important to make our rockets as light as possible. If we have a very heavy rocket, most of the thrust will be canceled by the weight, and we won't get very high. However, if we have a very light rocket, only a small portion of it will be offset the thrust, and therefore the rocket will be able to go very high. And now we can look at what the flight path of our rocket is going to look like. Our rocket will start on the ground, at which point we ignite the motor. However, the motor does not burn for the entire time it is in the air. And so at some distance up, the motor will stop burning. However, after this point, the rocket still coasts up a small distance before it begins to come back down. This point, at the top of the flight path, is what we call the apogee of the rocket. And at this point, our parachute comes out of the rocket so that it can slowly drift back down rather than crashing. And then finally, a rocket will land on the ground, likely some distance away from where we launched it. And this path that the rocket follows is usually what we call a parabolic flight path. And now we're going to make straw rockets, which is a fun activity that you can do at home. All you'll need is a few simple materials. A pair of scissors, any kind of tape, a pencil, and the straw rocket template, which can be found online. The first thing you're going to need to do is cut out the rectangle from the straw rocket template. And once you have that rectangle, you're going to need to wrap it around a pencil lengthwise and then tape it to hold it in place. Then, this tube of paper is what will form the body tube of our rocket. And next, we need to attach the fins. And so taking the fins, you want to line it up so that the bottom of the fin is aligned with the end of the rocket body, and then tape it in place. Then, flipping it over, we will attach the other fin in the same manner. Now that our fins are attached, we need to bend them so that they form a plus shape. To do this, take each of your fins and bend it so that they are 90 degrees and will form a plus shape when you look at it from the end. Now, the final thing we have to do is make the nose cone of our rocket. To do this, we can take the sharpened end of a pencil and pinch the nose cone shut and twist it around that. If you want, for more support, you can take an additional piece of tape and wrap it around to hold your nose cone closed. There is no set length you need to make the nose cone of the rocket. You can make it any length you want, and you can even experiment on different rockets with different nose cone lengths to figure out which one works the best. And finally, in order to fire this rocket, all you need to do is slip it onto the end of the straw and blow through this end, which will propel the rocket off the end of the straw.